everybody. So today's session is all about important terms in polymer chemistry. So there are 4 to 5 terms that you have to learn with which we'll be able to do any questions from previous year CSIR NET or GATE. Along with that, at the end of the session, we'll be also doing 2 to 3 sample questions so that it will bring you much more confidence. All right, so let's start. Important terms in polymer chemistry. Please note down the heading. And the first term that we are going to learn is about contour length. First one, contour length. So in the question paper, they might ask to find the contour length, or they can also ask us to find maximum end-to-end distance. Maximum end-to-end distance of a polymer. All right. So what is contour length? The formula is very easy. Contour length is simply equal to N into L, where N is the number of monomer units which are present in the polymer, and L is the length of one monomeric unit. Length of one monomeric unit. That's it. Very easy. So you'll be given how many units are present in the polymer into the length of one monomeric unit will give you the maximum end-to-end distance. Next one is root mean square length. Root mean square length. Now, most of the parameters that we are going to learn after this is related to root mean square length. So you have to know that it's represented as RRMS. Root mean square length, RRMS, is nothing. It's just root of number of monomeric units into L. N again denotes the number of monomer units throughout whatever terms we write. N is the number of monomer units and L corresponds to the length of one monomeric unit. Okay, so that's all about RRMS, root mean square length. Third one is not asked yet, but then you can write most probable length of the polymer. Most probable length, which is RMP. RMP is equal to root mean square length into root of 2 by 3 it is. Okay, so already know what RRMS is. It is root N into L. L is not within the roots, so pay attention to that, okay? L is outside the root. Into root 2 by 3 is the equation for most probable length of the polymer. Most probable length. Fourth one is mean end-to-end distance. Mean end-to-end distance. Mean end-to-end distance represented by R mean. R mean. R mean is equal to root of 8 by 3 pi into root mean square length. Or if I have to expand, it is root of 8n by 3 pi into L. Mean end-to-end distance. Now, a very similar term to this, which has already been asked, is something called average end-to-end distance, but there is a difference. Please note it down. Average end-to-end distance. Average end-to-end distance, and in brackets, in units of segment length. In units of segment length. So see, this has already been asked. you might feel that mean end-to-end and average end-to-end are the same because literal meanings of mean and averages are the same. But you have to pay attention. If they ask to find the average end-to-end distance in the units of segment length, then it is just equal to root n. It's already been asked in CSIR once, so pay attention. It's just root n. Root n. All right. Now, the last parameter is radius of gyration. Radius of gyration, notated by RG. RG, the derivations and all are not required. You need only the formula. It is the root mean square length divided by root 6. Or root n into L divided by root 6. This is radius of gyration. So we have learned 6 terms: contour length, root mean square length, most probable length, mean end-to-end distance, average end-to-end distance in the units of segment length, and radius of gyrations. Let's do some sample problems and then you're ready to go. Okay, so first question. The average end-to-end distance of a random coil polymer of 10 to the power 6 monomers. So it's already given that there are 10 to the power 6 monomers, and see what is given in the question. In units of segment length. So we already know that the average end-to-end distance in units of segment length, if asked, is just simply root n. The value of n is given, which is 10 to the power 6. So root of 10 to the power 6 is 10 to the power 3. Correct answer is option D. Correct answer is option D. Question was asked in CSIR December 2015. Very easy. Very easy question. Okay. Next question. The contour and root mean square length in nanometers of a polymer chain modeled as a random coil with n is equal to 1000 and L is equal to 150 picometers are closest to. Very important. See, here they have asked the question to be, they have asked the answer to be reported in nanometers and the question is given in picometers. So you should know to interconvert between them. What is 1 picometer is equal to? 1 picometer is equal to 10 to the power minus 12 meters. And 1 nanometers is equal to 10 to the power minus 9 meters. So you should know this relation, otherwise you'll get it wrong. So let's start. What is given? N is given, 1000, correct? L is also given, which is 150 picometers it is. So instead of picometers, I'll write it as into 10 to the power minus 12 meters. Now, if I have to convert it into nano, I need 10 to the power minus 9. So what I'm going to do is I'm going to divide it by 1000. I'm going to multiply it by 1000. Correct? So now what this will become? L is equal to 150 by 1000 is 0.150 into 10 to the power minus 12 into 10 to the power 3 is 10 to the power minus 9 meters, or I have got length in nanometers, 0.150 nanometers. Okay, that is easy. Now, first thing is to find the contour length. Contour length is nothing. We have converted into the required units. Contour length is N into L in nanometers because that is what the questioner wants. So that is 1000 into 0.150 nanometers. Now this is 150 nanometers. So contour length is 150. So if we check, it's not option A, it's not option B, it's either C or D. It's either C or D. Now, what is the next thing that they want? Root mean square length. Root mean square length is also very easy. All you have to do is root of N into L in nanometers, you already know. N is 1000 given in the question. L is converted to nanometers, 0.150 nanometers. Now let's check what root 1000 is. Root of 1000 is 31.622 into 0.150 nanometers. Okay, so I'm getting 4.74 nanometers is my root mean square length. 4.74. So it's not option C, it's option D. Correct answer is option D. Okay. This question was asked in 2018. All right. Next. The radius of gyration. Now, this was a controversial question. Please mark this as important. The radius of gyration in nanometers rounded off to 1 decimal place for a 3D random coil of linear polyethylene of molecular weight 8,40,000 is dash. Given the CC bond length is 0.154 nanometers. So first of all, the units in the question has been asked in or is being given in nanometers, and they want the answer also in nanometers, so the unit conversion is not required. So we are safe. Okay, now this question is important because this question was challenged by the students, but still the gate people were not able, they were not ready to change the answer. So the approach is a bit tricky. Let's try to understand. Okay, asked in gate 2022. So they have said that there is a chain of polyethylene. Now we know ethylene, this is ethylene, which undergoes free radical polymerization to form polyethylene, correct? So this is one monomer, this is two monomer, and so on. You can have n number of monomers. So actually this is our monomer. This is actually our monomer. What is our monomer? CH2, CH2. That is our monomer. Okay. Now the thing is, in the question, what they did is they took CH2 fragment as the monomer. So I tried the question by taking CH2 as the monomer. We are not getting the answer. So we need to take CH2 as a single fragment, and that is taken as the monomer. So I'll tell you how the question is being done. So when you take just CH2, what is the weight of the fragment? So the fragment considered is, so this is a usual case. So I'm rubbing it off because that is not what we need. CH2 is the fragment that is required. Okay. So fragment considered is CH2. And what is the mass of one CH2? 12 plus 2, which is 14 grams per mole. So from which we'll get N, the number of fragments in the polymer. Number of CH2 fragments in polymer can be found by total mass of the polymer is 8,40,000 and the mass of one fragment is just 14. So when you divide it, you will get the value of N as 60,000. You will get the value of N as 60,000. Now you have to find the radius of gyration, for which you have to know N and you have to know L as well. Okay, so pay attention. We are taking CH2 as the fragment and not CH2. If you take CH2 as your fragment, your mass of the monomer will be 28 grams per mole and your N value will be 30,000 and you will not get the answer. Conventionally and ideally, that is the right procedure because this is our monomer. But surprisingly, they have taken CH2 fragment. So next time, if they repeat such type of question in GATE, make sure that you make this approach because we have a reference now to challenge them if they say that this path is wrong. Okay. All right. So that is done. Now we need to find L. Already they have given the carbon-carbon distance. So let's say this is carbon and this is another carbon. So this is what is given. This distance is what is given as 0.154 nanometers. 0.154 nanometers. Okay. So we have a CH2 fragment, we have another CH2 fragment. We need to get the length of one fragment only. That is one carbon unit only. So from the center until this point, it will be 0.154 divided by 2. And from the center to the other end, it is going to be 0.154 divided by 2. So the total length of this carbon unit only is going to be L. Correct? That is our L. What is length? Length of the monomer unit is what we want. Here the fragment considered is CH2, which has only one carbon. So we need to get the length of just one fragment. And L is equal to 0.154 by 2 plus 0.154 by 2, which is 0.154 nanometers. Okay. So now we are ready to go. Radius of gyration is equal to RRMS by root 6. Correct? What is RRMS? Root of N, which is 60,000, into L is 0.154. We need to put them in nanometers because they have asked to report the answer in nanometers, divided by root 6. I've already calculated the answer. I'm getting 15.4 nanometers. So the answer in the answer key was given between a range of 15.2 to 15.6. This was in the key. Conventionally, let me tell you again that the monomer has to be taken of mass 28. Then N is going to be 30,000. And your monomer length, okay? Your monomer length is, this is CH2, this is also another CH2. So this is the total length. So from this point to the next point, 0.154 it is, correct? Now from the end of one carbon to the center, this is going to be 0.154 by 2. And from this center to the other end, it's going to be 0.154 by 2. So total, if you add all of these, you will get 0.308, ideally. So this should be our ideal L, this should be our ideal N, but that's not the answer which was given. I repeat again and again. So in the upcoming GATE exam, if they put a similar question, do have in your mind that the fragment that they had taken is not the monomer fragment, but the smallest carbon fragment, which is CH2. Okay, because we have a reference which was put forth by them only for reference if they change. Okay, so this question is important. And with that, we wind up the session. Very easy peasy, but important sessions from polymer chemistry. Okay. So I hope you have understood it and see you in the next. Bye-bye.